Hi guys. All right, so we're going to start with warm-up number 9. I encourage you to pause this warm-up whenever you need to catch up if I'm going too fast. First one we're going to do is going to be the parallel tangents. Remember, parallel tangents are going to occur where the slope is the congruent or the same, and your slope is going to be your derivative. Now, we do know how to take the derivative of g to the x, but we are a little shaky on f of x. That's something we're going to learn how to take the derivative of later. So right now, we're going to let the calculator do the work, and we're going to try and ingrain some good habits here in the very beginning. So I want you to put your f of x in your y1, and I want you to put your g of x in your y3. That's because in y2 and y4, we want to put your derivatives. And we're going to let the calculator do the muscle work on this. So we're going to go to the screenshots on the calculator, and these are the settings you need to have on your calculator. First of all, you need to be in radians. You're always in radians in calculus. As I said, we're going to do y1 is going to be your first function. Y2 is going to be your derivative of that function. And when you're putting your derivative in, it's going to be dx. You're going to need to fill in that x. If you hit alpha F4 on your calculator, it'll let you choose the y1. And then you're going to need to fill in this x equals x here. And then same thing here, alpha F4 down here will give you the y3. You can't really tell from this shot, but this is blacked out. Notice how this equals sign is not blacked out. You need to arrow over to where you're hovering over the equal sign and hit enter one time so that this function is turned off and this function is turned off. When you're graphing these, you don't want it graphing more than you can keep track of. We don't need the graphs of the original functions. We need the graphs of the derivatives because the derivatives are the slopes, and we want to know when the slopes are equal. So what you're going to be doing is you're going to be calculating when the slopes are equal by finding their intersections. Also, I set my window for the appropriate domain restriction, and then I looked at my table of values to see what sort of range yielded that kind of domain, and that was I got a good picture of the graph from -2 to 2, and this is what your graph should look like. Okay, and then I just did second calculate intersection, and I did both intersections here and here. Go ahead and pause the video and do all of that on your own to make sure that you know how to do all of this. And in the end, your answers should be at x equals 0.194 and 2.805. And remember, in calculus, the standard is 3 decimals. When it's a carry-on decimal, carry-on run-on number, irrational number, you're going to always carry to 3 decimals. Okay, the next warm-up, this is telling me this is my coordinate point, so it means it's going to be going through the coordinate point 3, 4. And it's also telling me that my slope at x equals 3 is 5. So I can go to y minus y1 equals m times x minus x1, the greatest of all linear equations, and I can say y minus 4 is equal to 5 times x minus 3. Okay, and I actually don't have to distribute. I don't have to do anything. This is a perfectly acceptable answer on a test, on a calculus test, on an AP exam. And just for giggles, we're also going to do a normal line. It's going to have a perpendicular slope. So in this case, my slope is going to be -1/5. So if I ask for a normal line, and this is back to making sure you follow instructions very carefully, my normal line is going to be the same process as before, except my slope is different. So it's going to be y minus 4 is equal to -1/5 x minus 3. And this last one is just the beginning of you needing to really know your derivatives of all your functions. I'm going to rewrite some of them so I have room for all of this. So I'm going to rewrite it sine x plus cosine x plus e to the x plus 4x to the fifth. And then this is going to be plus 3x to the negative 1 because I'm going to want to use the power rule that we're going to talk about in a little more depth, or that we've already talked about from the other day. So then this is going to become plus 2x to the negative 3 plus 4. Okay, now I'm ready to take the derivative. Okay, derivative of sine is cosine, so cosine x, and the derivative of cosine is negative sine. So this is going to be minus sine x. Derivative of e to the x is e to the x. Then your power rule says you bring the 5 down, multiply by the coefficient, and subtract 1 from the power. That's going to be 20x to the fourth. Again, your power rule says bring your coefficient down, your power down, multiply by the coefficient, subtract 1 from the power. And then the derivative of 4 is just going to be 0. You can leave it like that, or you can rewrite these last two as negative 3 over x to the positive 2, just using your exponent rules, minus 6x to the positive 4. I don't have a preference. You can leave them in either answer form. It's easier to leave it as a power just in case I'm going to ask you to take the second derivative.